Hi everyone, I'm Li Qu from Zhejiang University. Today I will present my latest work, VisCourt, In-Situ guidance for interactive tactic training in mixed reality. A tactic represents a series of specific team actions to achieve a goal. Actually, tactics have various representations. Basketball is typically a team sport, and effective tactics are essential to improve a team's performance and enhance the winning rate. However, learning basketball tactic is important but challenging. Players need to know why this tactic or how to execute. To improve players' tactical skills, convention tactic training in basketball primarily involves the emerging training such as watching tactic board or augmented tactic video. And afterwards, the coach organizes the players to practice. This routine can be summarized into two stages: the comprehension and the execution. It is clear that it evolves from a passive observation approach to an immersive interactive process. Means that there exists gaps between comprehension and execution. To bridge the gaps, the first challenge is to support the interactive learning. Many works turn to the power of AR and VR for physical training, but they lack the context for teamwork. On the other hand, due to the limitation of VR, we consider MR is more better for learning in practicing. For the second challenge about guidance, there exist various forms of visualization to guide movements. However, it's empirical to apply this directly due to the perspective shifts and change of environment. Thus, this motivated us to explore a novel training method. We propose VisCourt to improve the tactic training experience through a mixed reality environment. We set up the formative study first. Our motion capture environment is based on easy mocap. In collaboration with a university-level professional basketball team, we initially acquired a tactile simulation corpus and its what-if breakdown. Our formative study followed a user-centered approach. At first, we interviewed coaches and athletes to gain insight into how they learn from current training routine and the challenge they encounter in that process. However, it was noted that individual tactical training was limited. After that, we invited participants to engage with our prototype to follow the avatar's movement without guidance and collect their feedback on any confusion or problems. The initial feedback confirms the necessity of guidance. After interview, we conduct video analysis to explore the required augmented tactical information and to understand how this guide players. Thus, we deliver the summary of the gaps. For attention, what players should focus on. For comprehension, what is the impact of the tactical movements. For execution, how to execute it right in both spatial and temporal. Therefore, we conduct our design exploration. An important question is how to display data for guidance within situated. We characterize the 4 design goals and then propose a design framework. As the situation aspect, we address when to display in-situ guidance. For the data, we summarize what augmented tactical information should be presented. At the object level, we proposed where the guidance can be laid out on. We divide a tactical scenario into 3 situations: the trigger in preview, moving in movement, and the subsequent changes in review. We classify data from high to low semantic levels. In tactic level, what-if scenarios represent the variations of the tactic. Region of interest is the representations of an open space. Movement data as a form of spatial temporal data encompass space for where, time for when, and object for what. We conclude them in spatial relations, temporal relations, and trajectory. The object data encompasses the physical attribute of objects. References are of significant interest in this work due to their ability to lay out visual guidance. With only close annotations, we can determine visualization elements except visual types. This framework allows us to focus on refining the design space for in-situ guidance with the next design iterations. Finally, we designed our system VisCourt, contains step-by-step learning and run-by-run practicing session. With an design space corresponds to the gap participations. Here is the demo. VisCourt starts with the step-by-step learning session. Upon choosing the span pick-and-roll tactic, users enter tactical scenarios consisting of preview, moving, and review phases. Inside an avatar, users watch next stage movement guidance, including a ghost guide during the preview. We demonstrate various in-situ visualizations with augmented tactile information from our design spaces and provide feedback based on the user movement. In this tactic, users learn an isolation play, deciding to execute a layup or a mid-range shot in the final situation, and reacting to defensive player changes. After learning, users can engage in round-by-round practicing. Wait a minute for the video. After learning, users can engage in round-by-round practicing to keep pace with the team's tactical execution. We have set up text points to collect data based on the breakdown, thus support the performance review. VisCourt offers the following action to improve usability. I think something error on my video. Sorry. VisCourt offers following action to improve usability. User can choose different tactics, training sessions, both learning or practicing, or specific situations, and switch perspective and avatar. VisCourt also enables the play, pause, and rewind through the positional movement of the user. Thus enable users to switch between what-if scenarios, thereby enhancing the decision-making ability. We conduct a user study to evaluate whether VisCourt can assist users of different skills levels in tactical training. We recruit 12 basketball players and conduct the study in person within a half-court basketball setup. All users successfully complete the tech training in VisCourt. First, they thought VisCourt is helpful and has training compatibility, as we can see from the quantitative result. For each in-situ visualization, we gather subjective ratings. Users agree that in-situ guidance is helpful, and also effectively helps them understand augmented tactical information. The majority of participants express this system in quickly identifying open spaces and understanding the tactical goal. Thus, our in-situ design bridges the existing gaps. Finally, the performance review indicates that participants' skills have improved in our routine. Additionally, we found that bullet time is useful for perceiving the timing. In conclusion, we contribute a user-centric design process of in-situ guidance and a system VisCourt, as well as lessons learned derived through the user study. However, our work still has some limitations, including limited user support, predefined tactical simulation, and so on. Thus, we consider the flexible solutions for future work. By the way, after reviewing the feedback from VisCourt, we found that what-if scenarios can be well presented in MR. This allows users to improve their on-field vision and decision-making ability. On the other hand, the concept of visualization in motion is still worth exploring in sports XR. We thank the funding agencies for their generous support. That's conclude my presentation. I'm glad to take any questions. Thanks for your listening.
Thanks so much for the presentation. You can line up over here if you have any questions.
Hi, good afternoon. Thank you for your presentation. I think it's really interesting and insightful. Actually, I'm also interested in the sport visualization as well as the combination between visualization and XR interaction. So in your just presentation, I noticed a concept maybe named Bali time. I think it's really interesting. It's really inspired me. I think maybe it brings some new possibility for the sport visualization, especially in the XR surrounding. So I want to know, in addition to the Bali time concept, are there any other novel interaction or novel concept in your project, maybe named VisCourt? And do they have any implication or other potential application space in the sport visualization as well as the visualization in XR? That's my question. Thank you.
Yeah, thank you for your question. We truly found some implications for the future sports XR for the training. For example, the Ghost for preview via playback control shifts the learning to exploratory. An interesting aspect of our design is the introduction of Ghost in the preview to show the key movement related to the decision making. User can freely switch and enter any branches, exploring what if under the different situations. This approach transforms the learning tactics routine into an active exploration. By enabling users to visualize and interact with this tactical what-if information, we encourage a more immersive experience, fostering a more engaging and motivating approach to the tactical training.
Okay, thank you, insightful. Thank you.
Thank you.
Hi, Ian from CMU, and I have a question. And you mentioned that the what-if scenarios as an important and common scenarios for sense-making techniques for sports team coaches. And I'm just curious about, could you please provide more details about how to simulate such scenarios in real-world application? Thank you.
Yeah, thank you for your question. Actually, we now based on the mocap for the tactic simulation. However, relying solely on the motion capture for tactic simulation is not sufficient. Traditional tactical summarization relies on game videos, which often require a lot of manual annotations, and the sketch or other ways by using large language model for querying that directly converts from the video to the vect. May be helpful for the generalization of what-ifs in tactics. To overcome the limitation in enriching our tactical contents of what-ifs, we will use some maybe generated algorithm for the game situation, such as maybe multi-agent reinforcement learning, which can be more effective. Additional supporting the real-time motion reconstruction from the video recordings, maybe expand the tactic database or even for the spectators' experience. That's all.
Okay, thank you so much.